Hey everyone, welcome back to the Data Hustler. Today we are diving into 4 super important Pandas concepts that every data engineer is expected to know. I will walk you through real code examples, expected outputs, and where these are used in real world projects or interviews. Let's jump in. For today, our first problem state involves a combination of group by and aggregation. You have sales data. Find the total revenue per region. We are starting by importing the Pandas library using the alias PD. Pandas is one of the most powerful Python libraries used for data manipulation and analysis. If you are working with Excel-like tables or SQL-style data in Python, Pandas is your go-to tool. Then we are creating a data dictionary. Here we are defining a Python dictionary called data. The keys are region and sales. The region key holds a list of regions, while sales contains the sales number for each corresponding row. So for example, the first record means the East region had sales worth 200. So our problem statement once again is we have to find the total revenue per region. Give a crack by yourself before looking into my answer. Alright, here is how I would do it. Here we convert our dictionary into a pandas data frame using pd.dataframe. This creates a table-like structure where each row represents a record and each column represents a feature. In this case, region and sales. The resulting data frame look like this. 2 columns region and sales, and we are grouping by each region and their total sales as well. This is the most important line here. We start by grouping the data frame by the region column using .group by region. That means Pandas will organize the rows into groups. One group for east, one for west, and one for south. Then we access the sales column within each group using sales and apply sum to get the total sales per region. So for east we add 200 and 300 to get 500. For west we add 150 and 100 to get 250. South only has one row, so it remains 400. Finally, we use the reset index, which converts the grouped result back into a clean data frame with a default numeric index instead of keeping region as the index. Then we have written print revenue by region. This simply prints the final output data frame, and here we have the final output as well. And just like that, we have our total revenue per region in a neat and readable format. So why is this important? This kind of data summarization using group by and sum is extremely common in data engineering pipelines, whether you are calculating sales, counts, or any aggregate metric from raw data. I hope this makes sense. Let's move to the second problem statement. Handling missing data. Fill the missing values with column mean. So first we import numpy as np. This is needed because we will be inserting np.nan values which represent the missing data into a data frame. Next we define a dictionary called data, which contains 2 columns, customer and spending. Customers B and D have np.nan in the spending column, meaning their spending information is missing. Now pause the video now and try to write the remaining code by yourself to fill the missing values in this column with the mean of the column. Alright, here is how I would do it. We convert this dictionary into a pandas data frame using pd.dataframe of data. Now we have a clean tabular structure with the customers and their respective spending. Then here comes a key part. df of spending dot mean. Calculate the average of the available non-missing values, that's 100 and 300, giving us 200. Then fill NA replaces all NaN values in the spending column with this mean. So both B and D now have a spending value of 200. Finally, we print the data frame. The missing values are now filled with 200. Your output will look like this. This is a very common and simple technique used in real-world data pre-processing pipelines, especially in machine learning workflows or dashboards where missing data can break the logic. Clean data equals better models and better insights. Moving on to our third problem statement for the day, merge versus join. So our problem statement is to combine customer names and their orders. Here we are creating a data frame named customers. This will act like a master or dimension table holding basic customer information. It has 2 columns, customer ID and name. We have 3 customers, Alice, Bob, and Charlie, with IDs 1, 2, and 3. Next, we define another data frame called orders. This will simulate transactional data, like a fact table in a data warehouse. Here we have order records, each linked to a customer ID. Notice that Bob customer ID 2 has 2 orders, and there is a customer ID 4 who doesn't exist in our customer's data frame. Now pause the video here and try to write a code which combines customer names and their orders. Alright, here is how I would do it. Here the key operation is we are using merge to join two tables. We are merging on the customer ID column and setting how equal to left. This means we want all the records from the left table's customers, whether or not they have matching orders. If there is a match in orders, we get the order amount. If not, we get a NaN, which stands for missing. Finally, we print the merged data frame. Let's look at the output. See, this is the output. So all the details from the left table is merged and the missing value from the right table is filled with the NaN. Here Alice has one order, Bob appears twice, one for each order, and Charlie appears with a NaN since he didn't place any. This is typical behavior in left joins. Duplicates when there are multiple matches and nulls when there is none. This logic is fundamental in ETL workflows and interview questions, especially when working with the dimension fact joins or preparing feature data for ML models. Moving on to the final problem statement of the day, apply plus lambda. Here, a problem statement is to label salaries as high if above 70k, else low. Let's start with the data. We are creating a simple Python dictionary named data with the two keys, employee and salary. The employee key holds a list of employee names and salary holds their respective salaries. This is just a sample data to simulate a real-life employee payroll. Pause the video for a moment and try to write a code to label the salaries as high if above 70k, else low. I will see you on the other side. Alright, here is how I would do it. Here, we convert the dictionary into a Pandas data frame using pd.dataframe of data. This gives us a neat table format, one row per employee with their salary listed beside their name. Here is where the real magic happens. We are adding a new column called label to the data frame. To generate this, we take the salary column and apply a lambda function to it. The lambda x high if x greater than 70,000, else low. Part means for each salary x, return high if it's greater than 70,000, otherwise return low. The apply function in Pandas lets you run this logic for every row in the salary column. So what happens? John earns 65,000. That's less than 70k, so he gets labeled low. Sarah earns 80,000 and Mike earns 72,000, both above 70k, so they are labeled high. Finally, we print the data frame to see the results. Now we have three columns, employee, salary and label, where the label shows whether their salary is high or low based on our logic. This is a classic example of how applying with Lambda lets you add intelligence to your data. Whether you are labeling, flagging or transforming values row by row, it's one of the most asked Pandas trick in data engineering interviews. So make sure you get this 100%. These were 4 killer Pandas questions that will boost your confidence for any data engineering or analyst role. If this helped, hit that like, smash subscribe and comment below which question stumped you the most. Until next time, keep hustling. This is Data Hustler signing off. Bye-bye.